Welcome. Have you ever wondered what is really going on inside an AI agent? I mean, really under the hood? Well, forget all the complex frameworks for just a moment. Today, we're going to pull back that curtain and build one from the ground up, using nothing but pure Python. Let's demystify this thing together. We're actually taking a big piece of advice from the experts over at Anthropic. Instead of jumping into a massive framework like LangChain, we're going to start with the absolute basics. And why are we doing this? It's because this way, you'll truly understand the core logic, the fundamentals that make every single agent, no matter how complicated, actually work. So here's our game plan. We'll start with the why. Why this from scratch approach is so incredibly powerful. Then we'll build our agent up, layer by layer. We'll give it a brain, we'll give it a memory, we'll give it some superpowers with tools, and finally, we'll build the engine that brings it all to life. Okay, so with all these amazing frameworks out there, you're probably thinking, why on earth would I start with a totally blank Python file? Well, it really comes down to one word: empowerment. By building these core pieces ourselves, we're going to get a deep understanding of the fundamental logic that all of those fancy tools are built on top of. All right, let's get to it. Time to build our agent's brain. Now, at its absolute core, any AI agent is really just a large language model, like Claude or GPT, that's being guided by a very specific set of instructions. This is usually called a system prompt, and it's what gives our agent its personality, its purpose, its whole reason for being. And just look at how simple our starting code is. Seriously, we've got an agent class. The init method there just sets up our connection to the language model and gives it that core instruction, that system prompt we just talked about. And the chat method, that's just our way of sending a message to the model. That's it. That's our starting point. So let's put it to the test. We ask it a really simple question about apples, and it works. It gives a perfectly fine answer. But this first little taste of success, it immediately exposes our agent's biggest, most glaring weakness. What happens when we ask a follow-up question? And here is the problem in a nutshell. We tell it we have 4 apples. Then we ask how many are left after we eat one, and it's completely lost. It has no memory. Every single interaction is a brand new conversation. It has absolutely no recollection of the 4 apples we just mentioned. All right, time to fix this. It's time to give our agent a memory. Now, for now, we're going to implement a pretty simple short-term memory by just having it keep track of the entire conversation history. It's a basic step, but it is a powerful one. And you know what? The solution is surprisingly simple. We've just added a list here called self.messages. So now, after every single exchange, we add both the user's message and the agent's response right into this list. Then, with every new question, we send the entire conversation history back to the model. Okay, so let's rerun our test. And success! Look at that! We asked the same questions, but this time, it confidently tells us we have 3 apples left. Our agent now has context. It can actually remember what we were talking about. So our agent is getting smarter, right? It has a memory. But what about tasks that large language models, at their core, are just notoriously bad at? Let's push it a little harder. Let's give it some simple math. We ask it to multiply 2 numbers, and wow, as you can see, even a really powerful model gets this completely and totally wrong. It sounds super confident, but it is way off. And that's because these models are incredible at predicting the next word in a sentence, but they are not calculators. And this brings us to our next big upgrade. And this brings us to a really crucial insight. When an agent struggles with a task, we don't try to force it. We don't try to make it better at something it's bad at. Instead, we give it a superpower, or, more technically, a tool that can do the job perfectly. So giving our agent a tool is a pretty simple 3-step process. First, we just build the tool itself, like a simple calculator function. Second, we describe that tool in a special format called a schema, so the agent understands what it's for. And finally, we just connect that tool to the agent. So here's our calculator tool. Now, the execute method is simple. It just runs the math. But look closely at get_schema. This is the really critical piece. It's a structured description. It's like an instruction manual that tells the language model everything it needs to know: the tool's name, what it does, and exactly what kind of inputs it's expecting. Okay, this is a huge step. Our agent can now understand that a tool exists, and it can even ask to use it. But here's the thing, it can't actually run the tool on its own. It needs an engine to connect all the pieces together. It needs the agent loop. This quote from Anthropic's Barry Zan just hits the nail on the head. The agent loop is what elevates a simple chatbot into an autonomous agent. It's this continuous cycle of observing, thinking, and then acting that makes it so incredibly powerful. And this shows the new flow perfectly. See, it's not just a two-way chat anymore. It's this multi-step process. The agent tells our code, hey, I need a tool. Our code goes and runs it, and then our code feeds the result back to the agent so it can continue its line of thought. Our Python code is now the coordinator of this whole operation. Okay, let's watch this loop in action with a little word problem. The agent's first thought isn't to guess the answer. No, instead, it identifies the very first step. Calculate the mother's age. So it requests our calculator tool, our code runs it, and it gets the result, 50. But it's not finished. It's not done. With that first piece of information, it keeps going. It continues its reasoning. It realizes the next step is to find the brother's age. So what does it do? It calls the calculator again. Our code runs it, and it gets the next result, 18. And now, with all the pieces it's gathered, the agent puts them all together and assembles the final correct answer. It successfully broke down a problem, used a tool multiple times in a loop, and came to the right conclusion. This is a true agent at work. And there you have it. In just a few pretty simple steps, we've actually built a fully functional AI agent completely from scratch with its own memory and the ability to use tools. We now understand exactly what's happening under the hood. So the question is, what's next? To keep this journey going, I highly recommend you check out the full source code for this explainer on GitHub. And if you really want to go deeper, these resources from Anthropic, Aaron Dunn, and Dave Ebelar are just fantastic for exploring more advanced agent concepts. You've seen what's under the hood. You now understand the core components that power every single agent out there. And all those complex frameworks, they suddenly make a lot more sense, don't they? So the real question is, with this fundamental knowledge, what problems will you solve? What amazing things are you going to create? I honestly can't wait to see.